Which of the following statements are true with respect to heat and work? Statement 1 is they are boundary phenomena. Statement 2, they are exact differentials. Statement 3, they are path functions. Now we need to tell out of these three which are correct statement about heat and work. Let's understand all the three statements one by one. So the first statement is heat and work are boundary phenomena. Heat and work are boundary phenomena. Work is a transient quantity that appears at the boundary when a system changes its state due to movement of a part of the boundary under action of force. And heat, in a similar fashion, heat is a transient quantity that appears at the boundary when a system changes its state due to difference in temperature between the system and the surrounding. Okay, so both heat and work are boundary phenomena. So statement 1 is correct. Okay, now let's check statement 2, exact differential. In multivariable calculus, a differential is said to be exact or perfect. In multivariable calculus, a differential is said to be exact or perfect as contrasted with inexact differential. So let's understand what is inexact differential. Inexact differential. An inexact differential or imperfect differential is a type of differential used in thermodynamics to express change in path dependent quantities. More precisely, an inexact differential is a differential form that cannot be expressed as a differential of a function. Mathematically, suppose an inexact differential is commonly defined as a differential form delta u for which there is no corresponding function. Okay, so for this there is no corresponding function such that f is equal to integral delta u. Now let's understand it using first law of thermodynamics. First law of thermodynamics. We know according to first law of thermodynamics, change in internal energy is equal to delta Q plus delta W. Now instead of differential symbol D, here we are using for Q and W delta. Now internal energy U is a state function. Okay, so this is a state function. That means its change can be inferred just by comparing two different states of the system, which can therefore be indicated using U1 and U2 for two states. Now since we cannot go from state U1 to state U2 either by providing some heat delta Q or some work delta W. Therefore, the change in the state does not uniquely identify the amount of work done or the amount of heat transfer, but only the change in internal energy, that is delta U, which will be equal to U2 minus U1. Therefore, work and heat both are inexact differential. Okay, and U is a exact differential, that means the internal energy. Now the third statement says, statement number 3, that both work and heat are path function. Path function are properties or quantities whose value depend on transition from state 1 to state 2, or we can say the initial to the final state. Now heat and work are the two very famous examples of path function because these are the two functions depend on how the thermodynamic system changes from initial state to the final state. And as we have already seen that these two functions are brought together using internal energy concept, that is delta U will be equal to Q plus W. as we have already seen in the previous point. Now let's see some example of this. Suppose if we take a constant volume process, that means change in volume is equal to 0, isochoric process. Here the work done by the system is 0. That means delta U is equal to Q. Now if we consider, let's say, adiabatic process, okay, adiabatic process. So here heat interaction of the system is 0, okay. So here internal energy is equal to the work done. Now these are some of the examples that work and heat are path function. That means it depends upon the process, whether it is isochoric process or adiabatic process or isobaric process. So the relation between these two will be different in different processes. Okay, so statement 3 is also correct. So from the given options, we can say option B, that is statement 1 and statement 3, both are correct. For more information, you can refer to the NPTEL course, lecture number 10, Heat and Work on Concepts of Thermodynamics by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.